And let's read the question first. So there are two slabs. This is the refractive index √2. This is √3. The refractive index of the medium between the two is 2. The question is at what minimum angle, which is this angle, okay, should you strike the ray so that the ray is reflected at the two surfaces. So you can see the medium is where the ray is of refractive index 2. The slab above is √2, less dense, and the slab below √3 is also less dense. So total internal reflection will happen, but the question is what is the minimum angle of first strike so that you're also able to get total internal reflection on the second strike, which is here. Okay, so let me do. See, this question is very interesting because there is a way to think about it and look at the pattern. You know, I will start the question from here because I have to achieve the total internal reflection at this point, right? So let me attempt the question from this side. So my mu of the medium with respect to the slab will be given by 1 upon c, right? So this is 2 by √3 is equal to 1 by sine c. So I'm finding the critical angle here, okay? What is the minimum angle which I need to achieve total reflection at the second strike? If I am successful, I can adjust the first strike. So sine c is equal to √3 by 2, right? So this is c is equal to 60 degree. I need minimum 60 degrees here, okay? If I get it, I am at least able to graze, right? So that is my minimum requirement. How do I now remember? This is a situation like this where you have one strike, second strike, third strike, fourth strike, right? So all these angles are equal by geometry, right? Irrespective of the medium, you're coming in, you're going out, etc., etc. Now the danger is that if on the first strike you get an angle which is not 60 degree, you will not be able to achieve a critical situation of being able to jump off or bounce off from the second layer. So let's see what is the critical angle of this, just for the sake of it. Although I hope you've understood, but I will explain you. So let's say the critical angle at the first layer is this. So this is √2. Okay, sine c is going to be 2 upon √2, just like this, right? So because we're talking about moving from 2 to √2, I'm just finding the critical angle. So sine c will come out to be, sorry, this is going to be √2 by 2, okay? So √2 by 2, so this is equal to 1 by √2. So sine c is equal to 1 by √2, c is equal to 45 degree, which means if you send the ray here at 45 degree, you are certain that you will get a total internal reflection. But that doesn't serve the purpose, because if you do it at 45 degrees here, you will strike here at 45 degrees, right? So these are alternate angles, which means complete disaster, right? So the ray will come out. You don't want that. So what you do instead, instead of using the critical angle, use 60 degrees here. You're very certain of total internal reflection. The ray, because has been struck at an angle of 60 degree, which is greater than the 45 degree critical angle requirements of the first strike, will reflect back. And once it hits 60 degrees here, you're also sure that it will also at least graze, right? It will not go out. So the minimum angle at which you want the ray to be struck at the point Q is 60 degree. The critical angle of the first strike is 45. If you do less than 45, you are going to go out, right? So let's say you will go out like this. So this is not possible. This is not possible. At 45 degree, you will get a critical angle requirement met at the first strike like this, but you will not come back. And so you will have to increase the angle to an extent that you're successful here. And the success here is 60 degree, because that's a critical angle requirement at the strike 2. I hope you like this question. The answer is 60 degrees. Please don't forget to subscribe to this channel. You will find some excellent questions being explained to you, which will be very helpful to you for your upcoming examination. Thank you very much and look forward to see you soon.